The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thank you for joining us today for our webinar on gearing up for fieldwork. We're really excited to have you here with us, and we are ready to get started. This webinar is all about helping you feel prepared for fieldwork. Our experts are here to share their top tips to get the best environmental data from your meter or sonde. We'll also be providing some recommendations to make sure you're prepared every time you head out into the field. So first, let's meet those experts. First, Zack Henderson is one of our product managers here at YSI. He spearheads the development of new products, working closely with research and development to create cutting-edge technology for water quality monitoring. And next up is Curt Butler, application specialist and customer support. He helps some of the world's top researchers collect high quality data for their monitoring programs. And lastly, I am Michael Watt. I'm the marketing manager for emerging markets, and I'll be your host for the webinar today. So our presentation will take approximately 45 minutes and cover major topics from equipment selection to inspection, calibration, and other necessities for field work. But that's not all. Zack and Curt will be on hand for the remainder of our time to answer your questions about how to get the best results from your EXO or ProDSS. All right, so if you have any questions at any time during the live presentation, feel free to submit using the question box found in the right panel of your webinar interface. We will answer as many of these questions as we can during the second half of the webinar. But if we aren't able to get to your question here, we will certainly follow up with everyone over the next few days. Another quick tip is to disconnect from VPN if you're working from home. This can really improve your video and audio quality during the presentation. So with that, I'll hand it over to Zack to get us started.
All right. Well, thank you for the intro, Michael, and thanks everyone for coming here to meet with us today. We are really eager to get into these tips, and the first one we have for you is choose the right instrument. So if you're about to head in the field, you definitely need to know what to take with you. So what do you need? Well, the question of what do you need can be broken down into this question. When it comes to water quality, are you spot sampling or are you preparing to do some long-term continuous monitoring? Let's dive a little deeper into these terms. So if you are collecting a single point of data, think of it as like a snapshot of data right now. That is what we call discrete sampling or spot sampling. A handheld device like the ProDSS is typically used in these types of applications. Whether you are collecting in a shallow stream like our colleague in the image here, or if you are collecting a profile of a lake, it takes place at a single point in time, and we consider that spot sampling. Some examples of when spot sampling may be used over continuous monitoring might be when after spills happen and you need to know what is happening right then. Or maybe you are monitoring conditions related to fecal bacteria in a recreational area to make sure that the public stays safe. Or you want to measure the spread of algal blooms periodically in reservoirs. And finally, some groundwater wells that do not have to be sampled for health reasons and have lengthy residence times may just need a snapshot. So for situations like these, we'd recommend that you take a look at the ProDSS for your sampling needs. The ProDSS is a multi-parameter instrument that we explicitly designed just for spot sampling. And if you are not satisfied with a single snapshot of data and want a compilation of those pictures to paint a broader portrait over time, you will likely want to pursue continuous monitoring. During continuous monitoring, an instrument is typically left in the field at a single location over an extended period of time, years even. Some examples of when continuous monitoring is ideal are first when daily or annual loads, such as total suspended solids or metals, need to be very accurately computed. When oxygen levels in a wastewater facility need to be monitored to determine when pumps need to be turned on or off to save on electricity. To measure turbidity downstream from dredging operations to determine if sediment levels are exceeding standards and activities need to stop momentarily. And finally, if groundwater wells are used for drinking water, they may need to have water quality continually measured to indicate possible contamination. So the best instrument for continuous monitoring is the EXO sonde. And we offer several models to choose from. The EXO can be connected to a data logger so that the data can be telemetered or viewed in real time. Or the EXO can log data internally for viewing at a later date. Now, I know that we just mentioned the ProDSS and EXO, but if you are using any of our other YSI products, and even some other instruments, stick with us because we have these tips that are still suitable for you. So after you decide on your spot sampling or continuous monitoring instrument, the next question we need to ask is, what sensors do I need? With a wide variety of sensor options available, your story can most certainly be told using either of the monitoring solutions, ProDSS or EXO. Depending on the monitoring environment, the sensors chosen to tackle the job could be very different from one application to the next. As far as the choices go, there is no right or wrong answer. If your monitoring is related to one of the applications listed here, you are not looking at the same parameters, that is okay. These are simply ideas based on where our equipment is currently being used today. Regardless of what sensors you are using, know that you'll be looking at a long lifetime of monitoring with them if you follow the rest of the steps that we have coming up. Also, another tip is to make sure to check for any new sensors, like our nitroled UV monitoring sensor. So with that, I'm going to kick it over to my good buddy Curt to discuss sensor inspection.
Thanks, Zach. I appreciate the help in deciding which direction I want to focus on, discrete sampling or long-term continuous monitoring. Many folks are doing both, and hopefully the upcoming tips will be helpful to everyone. There should be some useful information, even if you're not using YSI equipment. So let's spend a little time discussing the transition from storage to a new sampling season. It's always very important to inspect the condition of your sensors before you start your maintenance and calibration procedures. There's no sense in taking time to calibrate if you have damaged equipment or obviously defective sensors. Take note on how your sensors were stored prior to use. Some of our optical sensors can be stored wet or dry, like the turbidity, nitroled, conductivity, total algae, FDOM, and rhodamine. But remember, just because these can be stored wet or dry does not eliminate the need to inspect them. You need to examine the face of these probes to make sure that they do not have a film or any other debris on the face that might interfere with readings or calibrations. If they do, simply use a lint-free cloth to wipe them down. And if there is severe buildup, you can even use a piece of moistened 3M Scotch-Brite to gently buff them clean. Do not use this pad for cleaning DO, pH, or other ISE sensors. It's a little too rough for them. The sensors that need the majority of our care are the DO, pH, and PHORP sensors. These sensors must be stored moist. So the first step of the new season is to determine if they were indeed kept moist in the off season. How do we determine this? By examining how they were stored. The top picture in this sequence shows a broken pH bulb. There's no sense in trying to do anything with a broken bulb. This is not repairable and is incapable of collecting any valid data. This pH electrode must be replaced. These other two pH electrodes look very much the same. It's tough to tell sometimes if the pH sensor was stored properly. The clue lies in the way the pH probe was found. Was the bottle that the sensor was stored in dry? If the sensors were stored on the sonde with some water in the bottom of the calibration cup, did it dry out over the storage period? If you discover at the beginning of the season that your pH sensor and your DO membrane cap were allowed to dry out, and this is your first clue that there is work ahead before you will be ready to collect good quality data. If you discover that your pH or DO were stored dry, all may not be lost. We have a chance to revive them with rehydration. If the pH module was accidentally stored dry, you can try to rehydrate it by soaking it in pH buffer 4 for several hours or even overnight, and then attempting calibration. If the calibration fails after this rehydration attempt, then the pH module is likely will be in need of replacement. Before I toss a pH electrode, however, there's another step that might be worth a shot. There are 3 levels of cleaning that can be done to a pH electrode. The first is very simple. Place a couple drops of Dawn dish soap in a plastic beaker of warm water and vigorously swish the sensor around to clean off any light debris that might be interfering with calibration. The next step, for more severe foggy type coating on the glass, you might try a short 20-minute soak in 1 molar HCl solution. This will help clean any tough contamination off of the glass bulb. The third and final cleaning attempt, and honestly my go-to cleaning procedure, would be another short 20-minute soak in 1:1 tap water to bleach solution. This will help break down any biofouling that might be clogging the reference junction and slowing down the response time of the pH sensor. And if you're doing both, the bleach and the HCl soak, make sure that you rinse very well between these 2 steps, as we do not want any mixing of the bleach and the HCl. And for those of you where HCl presents a problem for disposal, then just swap in vinegar in the place of the HCl. If the DO membrane cap dries out, place the sensor with the cap in a beaker of tap water for several hours, or you can even run the sonde and sensor in an aerated bucket overnight, then perform a calibration on the sensor. If after all of your best attempts to clean and rehydrate your pH electrodes and DO membrane does not bring them back to life, no problem. Just call our customer service team. Remember that the brains or electronics of that sensor of the DO and the pH do not need to be replaced, just the consumable portion, and we'll be glad to help you out if there's any confusion on that. After we're sure that the DO membrane cap was indeed stored moist, we also need to inspect the membrane for film, buildup, or scratched or missing paint. If there is biofilm, usually a gentle wipe with a moist chem wipe will be enough to clean it off. To clean off the surface of the membrane. Never use alcohol or any other harsh cleaners on the face of the membrane, as this will damage the paint. This paint coating is designed to help keep ambient light out of the sensor. This paint is not involved in the process of determining the DO value. That magic actually happens behind this curtain. However, if a quarter to a third of the paint is missing, then you will likely see unstable readings and have difficulty calibrating, and the membrane should be replaced. This process is super easy with the DSS and EXO. The new membrane just screws on, and it comes with a new O-ring, Krytox, and its own individual set of coefficients that you'll enter into the software prior to calibrating with the new membrane installed. Another important tidbit that I like to make note of is how old are my sensors? YSI makes this pretty easy and pretty simple to tell. Just at a glance, the serial number or lot number will give us a quick visual on age. Most YSI sensors and instruments have an alphanumeric at the beginning of their lot or serial number. The first 2 numbers would be the year of manufacture, while the following letter will indicate the month of that year, A being January, B being February, C, March, etc. We skip I because it's too close to the number 1. We do have a few new products that are only numbers. And in this case, the first 2 numbers will be the year, the second 2 numbers the month, and the next 2 numbers the day of that month. pH modules have a lifespan of about 12 to 18 months. And that is where whether you're actively using them or not. So whether you have the pH installed or it's in the box on the shelf as a backup, that sensor is going to be using itself up, whether in storage or deployed on the sonde. Pay closer attention to a sensor that's a year old, and if it struggles during the calibration process, then make sure you've got one on hand and ready to go if you should need it. So we talked a little bit about the sensors that are most common to both EXO and ProDSS, but for those of you that spend most of your time with long-term deployments, one of your biggest allies against biofouling and other buildup on the sensor faces during sampling is the central wiper assembly. It is crucial that you inspect the condition of the wiper block or brush assembly and the wiper itself prior to a new sampling season and after each deployment. One of the most obvious things to visually inspect is the wiper block assembly. Over time, the bristles on the wiper brush will become splayed and lose the ability to keep the sensor faces clean. If your brush looks like the photo on the right, it is time to install a new brush. To help prolong the life of these brushes, after each deployment, the brush should be cleaned out under running water using a toothbrush to clean the debris from the bristles, and then place a bread tie around the bristles to allow them to dry back in their original shape. Our friends at the NERS have had great success in soaking their clean brushes in very hot, near boiling water, carefully removing with tweezers, and then applying the bread tie. This extends the life of their brushes significantly. We also want to take a look at the black plastic parking garage where the brush comes to rest. Just make sure that it's not cracked and that all the debris has been cleaned out of the inside of the garage. The most important thing to remember about the central wiper is that even though it is very robust, this hard-working ally will need to come in periodically to freshen up the inside mechanism of the wiper. The repair center will install new O-rings, quad seal, and fresh grease to make sure your central wiper lasts a very long time for you. We recommend that this be done annually, and it's a good idea to have an extra central wiper in stock so that you can rotate your fleet without interruption of your deployment schedule. We have lots of other tips and tricks to help against biofouling, like heat shrink sleeves, copper and duct tape, as well as anti-fouling sensor guards. Make sure you check out our reference library on the website, where a previously aired webinar we did on anti-fouling just hit the shelf. Now, I just blew through a lot of information in this last section, so take a deep breath and let's summarize. Key takeaways. It's very important to visually inspect your sensors and wiper. Put on the detective hat and look for clues that might help you determine if you have issues before you even begin the calibration process. Also, just like the DO membrane cap, I feel like we've just scratched the surface. But remember, there's a ton of information available at the click of your mouse. You can check out the resource library, videos, white papers, and tech notes on our website. We also have all the manuals for your equipment that will outline proper handling, storage, maintenance, and calibration on there too. Okay, I'll give you a breather. Turn things back over to Michael for another quick poll.
Thank you, Curt. So we did have a few people join on after we got started, or might have had audio issues when they first joined, but don't worry. All of this content will be covered in the recording, and we will be sending out the recording in a follow-up email within the next couple of days. So to recap the story so far, you'll be prepared to get the best data by first knowing what equipment you need. Think about what types of research you'll be doing and the parameters you need to measure. You also need to make sure those sensors have been properly stored away. If you do have an off-season or extra equipment, while we pride ourselves on the rugged durability of our equipment, we all know that anything can happen out in the field. All right, so I'm going to hand things back over to our presenters in a minute. But first, we'd really like to get to know everyone here a little better with our first audience poll. So since this webinar is all about instrumentation, please let us know how you are using your equipment for water quality research. On your screen, you should see the first poll entitled, "Do you use your equipment for spot sampling or continuous monitoring?" And I'll just give you a few seconds to respond. And just as a reminder, on the right-hand side of your GoToWebinar screen, there is a question box. We do invite you to type in any questions you might have concerning any of the content that's being presented today. Both Curt and Zack will be on hand to answer your questions at the end of the webinar. All right, it looks like a majority of our audience has responded now. Just give just a couple more seconds for those latecomers. Terrific. Okay, I will close that poll and share our results. So Curt and Zack, it looks like 51% use ProDSS for spot sampling, and exactly 51% use EXO for continuous monitoring. Very interesting results. All right, Zack or Curt, who wants to lead us through tip number 3?
Curt, you want to take this one?
Curt might be on mute.
Curt was.
No
Thanks,
problem.
Michael. Appreciate that great feedback from that poll and appreciate all of you that participated. Zack, I've had so much coffee trying to stay awake for this time zone. If you don't mind, I'm just going to roll into tip number 3, properly maintaining your connections and connectors. During this webinar, we're going to be discussing ProDSS and EXO connectors. DSS connectors need to be clean and dry, while the EXO connectors need to be kept moist with Krytox grease. It is very important that you differentiate between the two, and if you're like most of our customers and using both, then it's very important that your team know the difference between the two connectors. The connectors or ports where the sensors are installed are just as important as the sensors themselves. Many of our instruments, like the ProDSS, require these connections to be clean and dry in order for their sensor to optimize its performance. Water, dirt, corrosion, or other foreign material found in these connections will likely cause interrupted signals and the collection of erroneous data. If the port or sensor connection appears dirty, flush them out with deionized or distilled water and then follow up with a rinse of isopropyl alcohol and a light blast of compressed air to help in the drying process. Make sure to allow for ample time for the port to dry once it has been rinsed before reinstalling the sensors. If you rinsed with alcohol, 15 minutes should be sufficient for drying. Otherwise, allow a couple hours to be sure that the connector is good and dry before installation. The double O-rings on the base of the ProDSS sensors need to be inspected also. Wipe them down with lint-free cloth and make sure that there's no debris around the O-ring. And then a little dab of Krytox grease on your fingertip applied until they glisten and you're raring to go. Once the ports are clean and dried and your sensors O-rings are properly lubricated, installing these sensors will create a waterproof connection. Be careful during this process that you do not damage the connection pins. This may result in costly repairs and unwanted instrument downtime. A moment ago, we were talking about the connections or connectors that must be kept clean and dry. Now let's talk about the wet mate connectors that are used on all the EXO sensors, SONs, and accessories. We don't have to worry about moisture getting into these connections. They can actually be installed in a rainstorm with no ill effects. The key with the wet mates is to grease the rubber around the connection so that it does not dry out, crack, and peel away from the pins. It is also just as important to remove old grease from ports and connectors prior to installing a fresh coat of grease. Piling new grease on top of old grease can be just as troublesome as no grease at all. Regarding the bulkhead ports, you can actually fill up the port with vinegar, like little cups, and let this sit for about 10 minutes. Then using a pointed Q-tip, gently rotate the Q-tip around and help free up the old grease and debris. Never force the Q-tip down into the hole, as this could damage them. Then feel free to flush these ports out with water and then wipe them down gently with a lint-free cloth. Now, using a stiff bristle paintbrush or a flux brush, apply a dab of Krytox to the brush and then to the bulkhead ports. This brush will allow you to get the grease into areas that your fingers can't reach. The connectors on the base of the EXO sensors can just be wiped down with a lint-free cloth, and then again, using a small paint or flux brush, apply a new coat of Krytox grease to the connectors. This is also a good time to take a look at the nuts that secure the sensor to the bulkhead. After years of use, these nuts, might get worn, and the little clip that holds the nut in place might wear out. These are available for field replacement and should always be part of your field survival kit, which I'll talk more about at the end of our presentation. One of the most important areas that will require your inspection is your O-rings. Think about this for a minute. We're about to drop hundreds of dollars worth of very sophisticated equipment into the water. If we do not pay proper attention to and care to our O-rings, we're putting this investment at risk. If the O-rings are in good shape, then a simple cleaning and relubricating will help ensure that your equipment is protected against moisture intrusion. Make sure to inspect the O-rings on your sensors, sondes, and battery compartment seals on your handheld. Replace any that are damaged or missing to prevent water or dirt intrusion. And if you're new to the field of sampling, these O-rings are the little, usually black rubber rings that you may see in different places on your instrumentation. Never add more O-rings in an attempt to make the seal better. That isn't how O-rings work, and you can actually promote leakage by doing this. Start with a visual inspection of the O-rings, looking for wear, nicks, or cuts, as well as dirt or debris under or around the O-ring. It's just as important that we inspect and clean the mating surface where that O-ring is going to seat. Something as simple as a hair across this area will compromise an otherwise perfectly good O-ring. If the area around the O-ring is dirty with debris, you can use a toothbrush to gently whisk that dirt away from this area. Then apply a dab of Krytox grease to your fingertip, and using your finger, apply the grease to the O-ring so that as you apply the new grease, you can feel for nicks, cuts, and malformations in the rubber. If you find any defect, replace the O-ring at once. Never use a sharp tool like a screwdriver or a dental tool to get under an O-ring to help you with removal, because if you scratch the mating surface under the O-ring, you will have rendered it useless. Usually you can just pinch an O-ring between your thumb and index finger to get a hold of it for removal. And remember, more grease is not better. Just a little dab will do you. Most of you are way too young to remember that commercial, so I'll just leave it at that. I want to mention the little O-rings at the base of the ProDSS and EXO sensor, the little ones just above the threads on the mounting nut. These O-rings are there only to help keep debris out of the base of the sensor. They don't have any impact on keeping moisture out of the connection. When these little guys look stretched out, remove and replace them to keep them from getting down into the threads of the sensor. YSI recommends Krytox grease because it's the very best. If you don't have that, silicone grease can be used. All right, you've probably had your fill of tips from me. I'd like to turn things back over to Zack for tip number 4, a fresh look at the important topic of power supplies and batteries.
All right, thanks so much, Curt. And that was a wealth of vital information. So feel free to take a break for a second and have another sip of coffee. And I will jump into the batteries. You are absolutely correct. The batteries and power are super important. So much so that one of the golden rules of tech support is to always check your batteries. Believe it or not, our tech support department gets more calls related to batteries than anything else. There are a variety of potential issues that come from battery-related problems, like leaks, for example. You always want to make sure when you are preparing for your equipment for the field that you check the battery compartment. There's always a chance that someone left batteries inside, which is a big no-no for long-term storage. Unless you submerge your equipment without the battery cover or port plugs, you should really have no electrical component issues from water. If we do see this type of damage, it is usually caused from battery leakage. Alkaline batteries can leak fluid that is harmful to the internal components of a sonde. Sondes that have been exposed to these types of fluids for longer periods of time will likely have corroded contacts and need to be sent to service centers for repairs. But if you catch this problem early, you can clean out the battery compartment using a mixture of DI water and baking soda to neutralize any acid, and so long as the spring is shiny and intact, the sonde should still function. However, if the spring is a greenish or blackish color, then it will likely fail eventually, if it even works at all. In order to prevent this from happening in the first place, just remove those batteries when the sonde is not in use. Another battery-related issue that comes up often is the use of lithium or nickel-cadmium batteries in a sonde. In concept, it sounds great. What could be bad about longer-lasting batteries? But it turns out that the voltage of these batteries is actually much higher than the traditional alkalines and can actually fry some of the electronic components inside the sonde. So we recommend that you stick with traditional D-cell batteries or rechargeable nickel metal hydrides where the voltage per battery is 1.6 volts. Finally, before you step into the field and do any serious data collection, be sure to swap fresh batteries in your sonde. It's common to hear about deployments where a sonde was deployed for long-term monitoring, only to realize it has been retrieved and that there is only a few days of data recorded. I even had a colleague that this happened to once or twice, so definitely learn from their mistakes. We should not use lithium-ion batteries inside a sonde, but we do have what I like to call a handheld battery caveat here. Lithium batteries are explicitly chosen by YSI for use in our rechargeable handheld meters. So if you're spot sampling with a ProDSS, that handheld has a rechargeable lithium-ion battery. And for that, we recommend that you keep a spare battery around or keeping a handheld charging cable nearby just in case that battery runs out. And speaking of those handhelds, when you go to store your handhelds that have the lithium-ion rechargeable batteries, make sure that you do not store them in a dead state. So what I mean by that is be sure to charge the batteries before you put them up for the season, and make sure you install the batteries in a handheld once in a while to check them to see if they need to be charged again. If they stay dead for too long, then they will need replaced. And if you find that they do need replaced, feel free to contact our customer service team, and we'll be happy to help you get set up again. So I'm going to go ahead and roll right into the next section here, and we're going to talk a little bit about software and firmware. These are commonly forgotten but vitally important. So if checking your batteries is the golden rule of tech support, then a close second is making sure your equipment is up to date with firmware and software updates. Golden rule number 2. This is especially the case with EXO and ProDSS instruments, where the instrumentation itself is continuously improved upon by our R&D teams. Chances are, if you are running older versions of software and firmware, any issues you may experience have been resolved in a later update. So before you calibrate sensors or record data, make sure you are up to date so you have the latest features available. So we have a software package called Core that was developed for both the ProDSS and EXO lines. You can download the software from the YSI website. I believe it's ysi.com/software. In the Core software program, we offer an automatic update feature under the menu settings so if you connect an instrument, it'll automatically update the firmware behind the scenes and apply it to your equipment if that firmware is found to be out of date. You will need a good internet connection and also administrative rights to your computer to perform the updates. One tip that I would suggest is to only perform firmware updates on your instrument when connected to a computer with a USB cable. Doing this ensures a smooth, successful update. All right, Michael, do you want to wrap up these couple sections and turn things back over to my good buddy, Curt?
You got it. Excuse me. You got it, Zach. Thank you for that. We're covering a lot of ground here. So as Zach mentioned, let's pause for another quick recap. You always want to inspect your instrument and sensor connections to make sure they are in proper working condition. And you need those good connections to make sure your data gets recorded correctly. You'll also need to make sure your batteries are fully charged, and it's a good idea to always have some extra batteries on hand. It also helps to make sure the firmware and software are all up to date if they've been stored away for a while, or you've purchased something new like the nitro-lead sensor. Okay, so we do have another question, another poll question for our audience today. Where do you collect water quality data? Feel free to select as many of the options that apply to your work. Just give a few more seconds for our audience to respond. Once again, just a friendly reminder that on the right-hand side of your screen, there is a question box. So feel free to type in any questions you might have for Zack or Curt, which we'll address at the end of the webinar today. All right, it looks like most of our audience has responded, and I'll share the results with everybody. And the winner is 78% with rivers and streams, followed by industrial applications and lakes and reservoirs. So thank you to everybody for responding to our poll. And now I'd like to hand things back over for tip number 6. Curt, would you like to help us out with this one?
Thanks for another great poll, Michael. I always love to see where and how our equipment is being used. Also, thank you, Zach, for some great information on batteries and my Achilles heel software. Let's spend some time talking about calibration. The first calibration of the season is particularly important as it may help uncover some issues that you might not have been aware of as you rush to bring the sampling season to a close last year. We could spend a whole day on calibrations, but we just don't have time here for a step-by-step today. You always have your operator's manual and your SOP to help you with the details, but I want to spend some time talking about some of the other things that might not be spelled out in the operator's manual. The first step to the calibration process is you always must verify that your temperature sensor is giving you accurate readings. All water quality sensors depend on a working temperature sensor to provide reliable data. If the temperature sensor is bad, there's no reason to proceed with calibrations. You will need to replace it before you move on because there's no way to calibrate a temperature sensor on most devices. In order to determine if your temperature is reading accurately, grab a NIST traceable thermometer or other certified thermometer and check it against your instrument's temperature. Make sure that the thermistor is within specification and you are good to go. Also, make sure to send your certified thermometer in to a lab to make sure that it remains within specifications. Typically, this might be once or twice a year, depending on the manufacturer of that thermometer. Next, you need to make sure that you're always using fresh calibration standards or solutions. Check the manufacturer's expiration date and note when the bottles were opened. The expiration date on the bottle is generally for an unopened bottle and can differ once the seal has been broken. People sometimes ask if they can use standards that are only expired by a month or two. YSI and most people's SOPs do not recommend or allow the use of expired standards. It is impossible to tell how they might adversely impact the calibration and thus lead to the collection of faulty data. Therefore, we do not recommend it. Please note that the expiration guidelines listed on the screen are for YSI manufactured standards. If you're using standards from another manufacturer, which is okay, be sure to ask their guidance on that particular product. In the previous slide, we stressed not using outdated or previously used standards. Error from reusing standards can come from cross-contamination of standards, debris on sensors, or even dilution from DI water used for rinses. So just make a habit of using pristine standards for your calibrations. However, one thing that you can do with your used or slightly outdated calibration standards is to reuse them for the rinsing part of the calibration process. I always save my calibration standards from today to be used during my next calibration. Save the standard that you just used in a separate bottle, and then use a Sharpie to write on the bottle the day that you opened it. Then write rinse only on the label. And I also put the letter R on the cap, so that if I grab that bottle off the shelf and the rinse only note is turned away from me, I'm still likely to see that R on the top of the cap. This rinse only standard can be used the next time that you calibrate as a rinse of that parameter. This keeps me from having to use brand new pristine standards for the rinsing steps during calibration. Although YSI does not write SOPs, ultimately this decision is up to you. We do, however, recommend a triple rinse, once with DI water, followed by 2 with the standard that you're about to calibrate. Having this rinse-only standard available can save you a lot of money by using it in this way. During calibration, take note of the sensor's response time and make sure that you allow the sensor enough time to stabilize before proceeding. If the sensor's having trouble stabilizing during calibration, you can expect similar issues when you're trying to collect data in the lab or out in the field. You may want to consider whether you need to perform some maintenance or replace a sensor if the problem cannot be resolved. The core software has a built-in Smart QC guidelines to aid you in the calibration process. A green Smart QC score means the sensor is calibrated properly and all parameters used to assess its performance are within factory specification. A yellow Smart QC score means that the sensor will still perform within factory specifications, but that during calibration, enough of an adjustment was required to suggest that the sensor is drifting from those limits or may soon require some adjustments, such as a new DO membrane cap or a new pH electrode. You might want to go back through the calibration process just to make sure you did all the steps properly. But in all cases, a yellow QC score is not an indication that that sensor is performing outside of specifications. A red Smart QC score, on the other hand, means that that sensor is not performing within factory specifications. Also, in some cases, a red QC score might mean that a component of the sensor is due to be replaced, such as the DO membrane cap, or the user has defined some other limit, such as the term expired since the most recent calibration. These examples are captured under the term soft QC because they are set by the user in core software, and such a setting will override a green Smart QC score when using the software. A red score is a stop in your tracks and investigate why you received this score. It might be serious, or it could just be a user-defined maintenance schedule that was ignored. Check out our Smart QC handbook that goes over the possible causes for yellow and red QC scores. After calibration, make note of indicators like the conductivity cell constant, pH millivolt slope, DO gain, and the QC score provided by the ProDSS and EXO software. These things will assist you in determining the success of your calibration. On a related note, you do not want to accept any calibrations that are out of range or giving warnings of questionable results. This indicates that there's a problem and further investigation is needed to determine the cause of the problem. Forcing a bad calibration is never a good idea, and it's likely that you will be collecting questionable data if you bypass all these warnings. For additional information on Smart QC and how to help remedy yellow and red scores, be sure to check out our Smart QC handbook. And a little side note, the Smart QC handbook is technically for EXO, but the guidelines are very similar for ProDSS and can still be used as a handy reference until we get the new ProDSS Smart QC handbook completed. Finally, be sure to dispose of your calibration standards according to your regional requirements. This varies from region to region, so contact your local water authorities or the water department to determine disposal requirements. For specific calibration standards, some commonly questioned standards are those for FDOM, ORP, and turbidity. I realize once again that we've been over a lot of info here. Key takeaways from this particular section: always verify your temperature sensor. That's the #1 thing to start with. If it's faulty and you don't catch it up front, all of your other time and efforts will be wasted. Always use fresh calibration standards. Depend on your SOP and the operator's manual for step-by-step calibration processes, and pay attention to the QC score and the help that it provides when completing the calibration process. Now I'm going to turn the reins back over to Zack for tip #7 while I freshen up yet another cup of coffee to bring me down the home stretch.
All right, go get that coffee, buddy. All right, so calibration is absolutely critical to a successful trip, and once that's completed, we want to do just one last thing before we head out, and that is finalize our instrument settings. So let's pop into the software and take a look at a few things that you need to be aware of. There are quite a few different configuration options to choose from, and they all relate to how you want your equipment to record data. For spot sampling, it may be important to have GPS coordinates logged along with your measurements. With technology like EXO and the ProDSS, GPS is built into the handheld and can be activated in the settings menu. Once activated, each recorded data point is tied to the associated GPS coordinates in the exported data files. Another relevant option for sampling and profiling applications is site support. EXO and ProDSS include the ability to tag recorded data files with site names. This is particularly helpful if your monitoring group manages several different sampling locations. Tagging each data file to a particular site is a great way to make a mountain of data files easier to sort through at the end of the day. In order to get an accurate timestamp, make sure that the system clock on your handheld, make sure to check the system clock on the handheld and your sonde. It is fairly common for people to forget to check the time in their equipment only to realize that all their data is tagged with the wrong times. Also, if you set an exact time for your sonde to begin logging data for deployment, it may not start when you want if the system clock is set incorrectly. I know the software actually has a function to sync the sonde clock with the PC time, so make sure you keep that in mind, and also make sure the handheld is consistent with the clock on the sonde. Lastly here, adjust your averaging if needed. There are 3 options. Default is what we typically recommend for those long-term deployments. We also have an accelerated and rapid mode, which we recommend for profiling applications. Also, for long-term monitoring, setting up your deployment settings is critical, especially if you're connecting your sonde to a data logger. In your deployment settings, you'll need to set an appropriate logging interval, and this is how frequently you want the sonde to record data, as well as make any adjustments needed to the SDI-12 or RS-232 output so that the data you're collecting aligns with that of the data logger you're connecting to. An additional feature of sondes that is pretty useful is adaptive logging. You may find this under the advanced settings. This allows your sonde to increase its sampling rate to capture events as they happen if certain thresholds are met. Examples of this would be pH or dissolved oxygen dropping below 5 and wanting to record data at 5-minute intervals during these periods instead of a normal 15-minute interval that it may be set up for. If you elect to set up adaptive logging, be aware that the battery life estimates do not take this option into account, so you may not get data over the full range you're expecting, depending on how frequently those thresholds may be met. Finally, you'll want to set up an appropriate wipe interval based on the power at the site. If you are running the SON solely on internal battery power, you may want to wipe less frequently, whereas if you're connected to a gauge with a solar panel and external battery, you may want to run the wipe cycle before every sample is collected. All right, Curt, I think our equipment has been inspected, calibrated, and now is set up. We are confident our equipment is good at this point, so what is the last awesome tip you have for our guests to get them ready for anything that comes up in the field?
Thanks, Zach. I know you're all probably thrilled that this is the last tip of the day, but seriously, let's talk about the need for a field survival kit. Our technical support team helps dozens of people every week and thousands over the course of the year, and occasionally they run into a problem where they want to help a person on the other end of the line, but that person does not have any tools or supplies with them to go through even the most basic of troubleshooting steps. If you're in the field and something goes wrong, it's important to have a go-to kit that will help cover the basics while you're out there. This is why we are recommending that you put together a field survival kit specific to your instrumentation and needs. We can give you some pointers on what to include, but you'll have to find what works best for you based on your situation. Think about where you're going. Consider the resources that you'll have once you get there. Sometimes the site is a long drive or boat ride, or you may have to hike a while before you get to the site, and there might not be anywhere to obtain parts for troubleshooting once you get there. First of all, do not be intimidated at all by this list. You already have the majority of this right in your lab. Here are some of the items that we might use in the field for cleaning or troubleshooting. First and foremost, make sure that you have some tools that will allow you to remove the sensor or battery cover. Those are the two fundamentally basic things that you better have with you. The EXO and ProDSS come with most of the tools that you'll need for many tasks, O-rings and Krytox grease, for example. So that's a good place to start when assembling your kit. In addition, the battery compartment tools, screwdrivers, small flashlight, compressed air, an extra wiper brush, lint-free cloths, DI water, calibration standards might be helpful just in case. Extra cables and sensors may be of use if available. And I always recommend taking some port plugs, which take the place of a sensor when the sensor is not installed. Of course, if you forget spare batteries, don't forget spare batteries, and make sure that any items in your kit that have limited shelf life be replenished on a regular basis. There's nothing worse than carrying dead backup batteries in your field survival kit. Some of these other optional items are for removal and prevention of biofouling and may be helpful to keep in your kit as well. Of all the things on this list, my go-to for hard fouling is the putty knife or scraper. But I always have the other items just in case I need to clean up and reapply anti-fouling material prior to redeploying. If you take a small survival kit with you and a problem arises, you're going to be in a much better position to do some troubleshooting and hopefully get back on track and possibly avoid an unnecessary trip back to the site. Thank you all so very much for attending today. We appreciate you taking time out of your busy schedules to be with us, and please be safe out there, friends. Now I'm going to turn this back over to Michael to wrap things up for us.
Thanks, Curt. We know we gave everyone a lot to look at in these last few slides, but don't worry. Again, we'll be sending out a copy of our recommended survival kit along with the recording of this presentation to everyone who registered and to everyone who attended here today. There will be a follow-up email, which can be expected to arrive in your email box probably end of this week or latest Monday of next week. So as a quick recap, here are the 8 big steps you can take to ensure the best results in the field. Make sure you've chosen the right instrument. Inspect your sensors and connections. Check your batteries, firmware, and software. Make sure everything is calibrated and your settings are finalized. And remember to bring that survival kit with you every time you head into the field. All right, we're just about to start our live Q&A session with Zack and Curt. But as we give them a minute to look over the questions in GoToWebinar, I have one more question for our audience, and that's simply, how can we help you? So on your screen, you should be able to see our final poll question, and we'd really love to hear from you. How can we help you? Please look over the options and select all that apply. Our application specialists are happy to help you select the best equipment for your work, or even provide live demos to make sure your team is properly trained. And we also offer services to get your monitoring sites set up, or we can even stop by for period maintenance if you need. We know how important all of the water quality research you do is, so we really want you to feel confident you're collecting the best data possible. We'll just give a couple more seconds for our audience to respond. Terrific. So a big thank you to everyone who responded in the poll. All right, one last note before we get to the questions. You can find recordings of YSI's past webinars on the YSI website. Recent highlights include a webinar about how the EXO nitrolead sensor has changed nutrient monitoring by making it easier and more affordable than ever. We also recently collaborated with SoneTech on the importance of gathering both water quality and flow data. And we also have our university series videos that go through all the ins and outs of both the EXO and ProDSS platforms. All of these can be found at video.ysi.com. So now it's time to hear from you, the listeners, in the question and answer portion of today's webinar. If you haven't already, please enter your questions, any questions you have, in the webinar questions panel. And this is your chance to get your questions answered by our product experts. Now, I realize that some of you might be a bit shy and might prefer to contact us directly rather. So we have included an email address, which will be coming up on our next screen. In fact, I can share that with you right now. It's right there. Feel free to contact us directly at this email address, and we will ensure that your question gets sent directly to a local product specialist.
Michael, I have a question here from Ron. Said, should I be removing my O-rings to clean and lube them? And Ron, that's a great question, and I should have probably gone into more detail on that when I was having that discussion about O-rings. But we don't recommend actually removing them in most cases because we run the risk of stretching them during that process. So we want to try to clean the debris gently with a toothbrush or a fairly stiff bristle paintbrush, so that we can clean the debris from between the O-ring and the mating surface, and then apply fresh Krytox with our fingertip. But I don't like to take them on and off, because every time we do, we're pulling that O-ring out over where it's going to lie, and it runs a risk of reducing the effectiveness of that moisture seal.
Excellent.
Zack, I've also got one here from Michael, if you don't mind me jumping into this one. Or I'm sorry, that's I'm trying to tell here. I can't tell if it's Michael or Derek, but anyway, if we need to be inspecting connections on sensors that are rarely or never removed from the bulkhead. I think I understand what he's saying there in asking, And the answer to that is a resounding yes. We need to inspect and remove sensors, even if they are rarely removed from the bulkhead, because they're, like, let's say, for instance, a turbidity sensor. You're not like pulling it to replace like you would a pH electrode or a DO membrane cap. So that sensor might remain in the bulkhead longer than the other ones. But it's important that we periodically remove that sensor, clean the bulkhead port, clean and relube the O-rings if it's a DSS, or the wet mate if it's an EXO sensor. And this takes me to another really important point along those lines. It's not uncommon for us to have, let's say, an EXO2 where the customer has all but one port. It's full of sensors, but one port is never used, so they have a port plug in that. So when the SON comes in after deployment, they remove all the sensors, go through their regular maintenance, and reapply grease to all the wet mates and so forth, but they leave that port plug in place. And over years of use, that port plug is being neglected and can be become a problem where the port plug itself will dry out and crack and allow moisture into the bulkhead. We don't want to get to the point where we ruin that bulkhead port and even possibly allow moisture to seep its way down through that unused port and damage some of the other electronics involved in the bulkhead. So yes, make it a standard routine to pull all the sensors on occasion, clean their connectors and relube, and make sure you don't forget about the port plugs.
Thanks for that, Curt. I realize that we are now at the end of our scheduled time, but just a message to our audience. If you are able to stay online, Zack and Curt will continue to answer your questions in a bonus after-hour session. If you do have to hop off this call, we completely understand, and we will include the bonus Q&A session in the recording. So please keep an eye out for that, as I said, in the next few days. If you do have to hop off, then thank you so much to everyone who is able to join us for this webinar. And we hope you found it helpful. And we most certainly look forward to seeing you in our future webinars. So wherever you are in the world, from everyone here at YSI and Xylem, we wish you success within your environmental monitoring efforts. Thank you very much. And for those of you who can stay online, let's move on to our after hours question and answer session with Zack and Curt. So Zack and Curt, if you don't mind, I'll go through some of these questions. Just call out if you would like to answer the question. Can the ProDSS measure fecal bacteria?
Yeah, I'll take this one. So we don't actually have a sensor specifically for measuring fecal bacteria on the ProDSS. But from what I understand, and Curt can chime in here too, I think if there is a presence of fecal bacteria, a significant presence in a water body, that would probably show up in some of the other more popular parameters, including dissolved oxygen, perhaps pH or conductivity. I don't know, Curt, did you have an opinion about that one?
Not really. That would be one I'd really rather defer to our scientific R&D team, and I'd like to be able to follow up with a more detailed response to that in an email if we could.
Sure. Yep.
All right. Let's move on to the next question. Would you still use a ProDSS to spot check to help validate EXO data if EXOs are more accurate?
Yeah, absolutely. Curt, I hope you don't mind. I'll take this one. The ProDSS, if you've noticed, the sensors appear very similar between the ProDSS and the EXO. And if you look at the specifications, a lot of them are consistent across both platforms, basically. I think there is some discrepancy between the performance of the temperature and conductivity sensor on those platforms, but in general, I would say the ProDSS is a great spot checker for if you want to compare with the data that's being continuously logged from an EXO.
And for sure, even though there might be slight differences in the specs, there's not enough of a difference between them that it would ever run the risk of you sampling and out of range on your, versus the EXO with the DSS. That's not a problem at all. As a matter of fact, that's a really handy way of going about that verification process. Michael, I've got another really good one here. It's really simple, but I think I probably skimmed over it. And Stephanie just wanted to know again what the ratio for the bleach was, and it's very simple. It's just 1-to-1 ratio of tap water to bleach, and it's a 20-minute soak. And the one thing I like to do is to follow that up by a few minutes of soaking in buffer 4, and that'll help leach that bleach back out of the reference junction that might have migrated its way back up into that reference junction during that initial soaking process. Good question, Stephanie. Sorry if I skimmed over that during that initial webinar.
All right, thanks, Curt. On to our next question. Please tell us more about ammonia sensor calibration and how to clean ammonia sensor in case if there is biased readings while calibrating and storing it in particular.
So I can talk a little bit about the calibration of the ammonia sensor, and I'll kick it over to Curt for some cleaning tips. But with the ammonium sensor is an ion selective electrode. Those need frequent calibration. If you're spot sampling or discrete sampling, pretty much every single day you want to use that sensor. We do recommend calibrating it. We recommend doing at least a 2-point calibration. And I think for best results, we actually offer a 3-point calibration that's kind of interesting, where the third calibration point is the same as the first calibration point, but we asked for a 10-degree difference in the calibration sample. So it's pretty interesting. You can read about the specific instructions in either the ProDSS or EXO manuals, user manuals there. And then one note about the storage of any ion selective electrode for at least for the EXO and the ProDSS. We ship these electrodes dry. And I think there's kind of been a change in the methods of storage for these electrodes over time. And I believe we used to ship them with a wet sponge, but now we've been advised that the best method to ship and store these electrodes is actually dry. And then just before use, you'd want to soak them in a standard solution overnight to kind of rehydrate the electrode. So anyway, I'll shut up for a second. Curt, did you have any cleaning tips or anything else to say about the ammonia?
Not really. I don't have much to add to that other than the fact that I'm reluctant to actually use any material on the membranes because they're significantly more sensitive than most. Most of the time I like to use a vigorous swishing of that electrode in a warm water solution, but I really don't have a whole lot to add to Zach's point. The only other thing I would say is when you're soaking that overnight is you'd want to soak it in the high standard as opposed to your low value standard that you're going to do the calibration with starting the next day. You always want to make sure you're soaking it overnight in your higher value. You got to just keep in mind, it's it's probably a good thing that I'm not in sales, and it's not a good thing that Zack, the product manager, is on here with us, because I can tell you a whole bunch of reasons why I don't like YSI electrodes, but they're a necessary evil. And the reason I say that is they're temperamental. They're not as accurate as most other sensors. They take more calibration. They're a pain in the booty to calibrate, and so at the same time, we sell a ton of them, and they're great for trending. They're just not, we're used to like a conductivity sensor being extremely accurate. And it's frustrating when we then go to another sensor where we really are dying for it to be as accurate as conductivity, and it's just not feasible. The water body is full of too many ionic substances for us, to be able to do that. But nevertheless, I like to use the old story about the two cities where one city is wastewater treatment plant is upstream, and they have a huge rain event, and they flush a bunch of raw sewage into the river, and the city downstream from them is using the YSI sensors to sample the water, and we call this the turd alert. So even though it's not extremely accurate, not like a conductivity sensor, it spikes, and they can say, wait a minute, today's not the day for us to be pulling our drinking water sample from the river. So we sell a ton of these sensors, and I know they're frustrating, but they are very temperamental and certainly need a little more attention than most of the other sensors that you're used to working with.
Curt, I love that. That's a whole new perspective on A Tale of Two Cities. So thanks for sharing that. Let's move on to our next question. Do zones need to be recalibrated after a battery charge?
No. Nope.
Sorry, Zack.
No, I think we both knew the answer to that one. So yeah, if you have to remove the batteries, if the batteries die, the great thing about the EXO at least, is all the sensors are smart sensors, and that means the sensors themselves hold the calibration internally in each and every sensor, and even if they lose power, they're not going to lose that calibration. As soon as you resupply power, then it can still pull from that most recent calibration. So the short answer is no.
Okay. What is the best flow for calibration?
I was just going to add that, it's one of the really cool things about that. Imagine having a telemetered system and you're watching your data on a daily basis, and then all of a sudden you see that, oh gosh, my pH electrode just died on me. You can literally calibrate a pH sensor in the lab, pull it from the sonde that you calibrated it on in the lab, hand carry it to the field, pull the sonde, remove the existing pH sensor, plug the new one in, and that sonde will immediately start logging new data on that calibrated sensor. Has nothing to do with loss of power, to maintain the smart calibration coefficient. So really good question, though.
Thank you, Curt. What is the best flow for calibration? Is it DO followed by pH followed by conductivity, or what would you suggest?
Well, so what I like to do, first of all, the first step in the process is always verify your temperature. You have to make sure the thermistor on your CT sensor is within specifications. If it's out of whack, then all of your other readings can be impacted. So you've got to start there just by verification against NIST traceable thermometer. And then what I like to do is to keep in mind that your conductivity is used in the calculation of your DO milligrams per liter, not the percent stat, but the DO milligrams per liter. So I always like to calibrate conductivity after verifying that the temperature is good. And after that, really, there's not a huge difference. I typically go ahead and do pH next, and all of my other optical sensors. For some reason, I'm just in the habit of saving dissolved oxygen for my last calibration. And the main reason that I do that is that my favorite form of calibration on the dissolved oxygen sensor is submerging the sonde in an aerated bath, 5-gallon bucket, 2/3 of the way full, air stone, been running for at least 3 hours. I have mine running 24/7 in my office. And when you put that sonde in the aerated bucket, the entire sonde will equilibrate extremely rapidly. And so that's why I personally save DO for last, just because all the other sensors are involving, my cal cup and the rinsing process and so forth.
Terrific, thanks, Curt. The next question concerns Pro Plus and Pro Quattro sensors. How do you mitigate pH sensor drift with every calibration? And just a special note that the units are being used mostly in seawater.
Yeah, all I would say there is just with respect to storage is when you're not using the sensor, the best way to kind of preserve well, just preserve the sensor, I guess, is to store it in its storage solution. I believe those sensors ship in a storage bottle that seals around the sensor, and keeping that sensor tip in its proper storage solution is a great way to preserve that sensor. If you run out of the storage solution or if it spills, I believe you can use the pH4 buffer solution as a good substitute. Is that correct, Curt?
Yes, it is. And, you know, I think part of that kind of depends also on how much downtime you're going to have between uses. One of the other things that you always want to remember is that when you come back from the field, it's really important. You know, a lot of times people will just grab a little sample water and leave in the bottom of the cow cup instead of having clean, fresh rinse with them in the field and you know, clean tap water in the bottom of the cow cup. So they bring sample water in the cow cup to keep things moist, put it away for storage without cleaning and rinsing, and then stuff starts to grow between that sampling session and the next. So one of the key things that I would recommend is that when you come back in from the field, rinse everything down, clean it really well, make sure that, you know, before you put the cow cup back on with a little bit of tap water in the bottom, that everything is good and clean and it's fresh and it's not, you know, it's not sample water and it's not even field water that, you know, it was fresh when you took it out, but you didn't really rinse things down well. So you've got a mixture of sample water with your clean water. We want to make sure that when you put that thing away, that stuff isn't going to automatically start growing. Keep in mind that reference junction that I talked about with that 1-to-1 tap water to bleach cleaning, that reference junction is what vents the inside gelatinous buffer 7 solution on a pH sensor to the atmosphere. And if it gets clogged with biofouling, it's going to extremely slow down the response time of that sensor. So now envision the fact that you're in the calibration process, ready to go out in the field the next time that you've had it in storage in some nasty water. So you put it in buffer 7 and everything looks pretty stable. Things are drifting a little bit. Your millivolts are kind of ticking along, but they're not coming to a complete stop. It's still rotating a little bit and shifting. The reason that is slowly continuing to adjust is likely because that reference junction has biofouling building up and it's slowing down the response time. So if you take that value and you accept the calibration, when indeed that, let's just say those millivolts were at minus 50 millivolts or minus 45 millivolts, and they really would have continued to adjust themselves to say a minus 15 millivolts if you'd have given it more time because of that slowed down reference junction. Well, let's say you complete a 3-step process of calibration of that pH probe. When you go to the field, your sensor's automatically going to start trying to re-equilibrate itself to what those actual values would have been. So the thing to keep in mind is that when your reference junction is slow, when you're in pH buffers, when you go, let's say, from buffer 7 to buffer 10, and it's creeping along, if it's doing that in buffers when a pH probe should be at its finest, it's going to be terrible in the field. So you've got to go back and try that 1-to-1 tap water to bleach to clean out that reference junction and try to speed up that response time again. That's going to get you in a position where you can better gauge whether or not your actual millivolt readings and your pH value are stable from one buffer to the next.
Terrific. Thanks, Curt. Do exoturbidity sensors need to be shaded from ambient light during deployment?
No, they do not.
Terrific.
That's a simple one.
The only caveat I would have for that is if you're in a very shallow stream and you have a horizontal, you know, a near horizontal deployment, you want to try to make sure that you're not pointing that, you know, that base of that sonde into the position where you're likely to get, you know, the majority of sunshine shining straight into it. Typically, the sensor guard is going to be plenty to protect that turbidity sensor from, from any ambient light interference. And the other thing that you can help to mitigate that is that if you are in that horizontal deployment, there's actually an inset, a little recessed area in the sonde that would allow you to put a pin in your deployment tube so that sonde could be exactly deployed at the same angle every time you put it into the tube. If you do that, then you could ensure that sensor guard also has one of those ribbed connections where it doesn't have one of the openings that's directly above the turbidity sensor, which will also help, mitigate any of those issues. But 9 times out of 10, it's not a problem.
Okay.
Yeah, that's really good clarification, Curt. Certainly if the sonde's in a vertical orientation with the sensors facing downward, not really an issue whatsoever. Exactly. And if you do have it in a horizontal orientation, just make sure it's not tilting upwards, and putting it in a deployment pipe will surely help as well. And it's just good practice in general to protect the sonde.
Thank you, Curt. Thank you, Zack. To our audience, thank you very much for attending our webinar today. We do realize there are still a number of questions that are remaining, but due to the hour, what we will do is we'll have either Curt or Zack or one of our regional product specialists reach out to you directly with answers to these questions. Again, thank you to everybody who attended, and particularly to Zack and to Curt. Thank you so much, gentlemen, for staying up so late in your time zone to supply us, our audience, with some great knowledge about ProDSS and EXO.
Thank you, Michael. It's been a great evening, and I really appreciate the opportunity to be with you guys. And until my next visit down under, thanks.
Yeah, thank you for inviting me. I'm super excited to be able to present to this group. So I don't mind staying up that late at all. So feel free to reach out anytime you need me.
Terrific. Thank you, everybody. Have a terrific day, and we hope to see you all again at our next webinar. Goodbye.